In the following series of videos, we're going to do problem solving for chapter 10. We'll be covering three main points. First, we're going to do a hypothesis testing for a mean when the standard deviation of the population is known. Second, we're going to do a hypothesis testing for a mean also, but when the standard deviation of the population is unknown. And finally, we're going to do a hypothesis testing for a proportion. We'll be using the following three formulas. To cover the first point, let us solve problem 1 from worksheet 4. Let us first try to analyze the given and extract the key values. When we say different than $5,000, this is the claim, this is what we're trying to prove. Different than means that we're facing a two-tailed test. $5,000 is our test value, this is what we're claiming the population average to be. The sample size is equal to 36 colleges, which means n is equal to 36. The sample mean is equal to $5,300, and this is our x bar, and the population standard deviation is equal to $600, which puts us in our first case that we are testing a mean and the standard deviation of the population is known. To solve this, we're going to use the 5-step hypothesis testing, and the significance level is equal to 5%. Question A. The distribution we should use is the Z distribution because we are testing a mean and the standard deviation of the population is known. Question B. This is the first step from the 5 steps procedure. We always state our claim in the alternative hypothesis H1 and its inverse in the null hypothesis H0. So if we're claiming that the average of the population is different than $5,000, this is stated in H1 and its inverse goes to H0, which is that the average of the population is equal to $5,000. Question C. This is the second step in which we state the level of significance, which is alpha, which is 5%, which is the level of error. Question D is the third step from the 5 steps procedures, which consists of calculating the Z. We use the first formula from the 3. Applying it will lead to a Z calculated equal to 3. Question E. This is the fourth step, and according to which we are going to make our decision. First, we draw a normal distribution, and since it is a two-tailed test, we draw two tails. 5% is divided by 2, so our error on the right is equal to 2.5, so is our error on the left. To find the Z critique, we should subtract 50% from 2.5. The area from the mean to Z critique is equal to 47.5%. We go to our Z table and search for 0.475. We find a Z critique of 1.96. If Z calculated falls between minus 1.96 and 1.96, H0 is not rejected, while if Z is higher than 1.96 or lower than minus 1.96, H0 is rejected. Question F. Based on the previous analysis, Z calculated is equal 3, which is higher than Z critique, which is equal to 1.96, so we reject H0 and we maintain our claim. Question G. P-value is another way to decide whether to reject H0 or not. The general rule is the following. When p-value is higher than alpha, we do not reject H0. When p-value is less than alpha, we reject H0. When in a Z distribution and facing a two-tailed test, p-value is equal to 2 times 0.5 minus the probability of occurrence of Z calculated. To find the probability of Z calculated, we go to the Z table. Z calculated in our example is equal to 3, so we search for 3.0 and 0.00. Our intersection leads us to a probability of Z calculated of 0.4987. When substituting it in the formula, we get a p-value of 0.0026, which is less than alpha, which is equal to 0.05, and thus leading us to reject H0. This result is the same as in the 5 steps procedure. By that, we would have covered the first point in our chapter.